These are two boxes, and one of them contains maths required to fix an aircraft and the other one contains maths required to design and build an aircraft. At first glance, you must be wondering, so what's the difference? They must be full of calculus, matrices, vectors. It's all same engineering. But I'm going to shock you. The difference in mathematics between these two engineering is very big. So in this video, I'm going to break down the differences between each mathematics required for each of these domains. So stick with me till the end of the video, because at the end, I'm going to do two exam questions from the same module, basic aerodynamics, but for these two exam questions, they require two different skill sets in mathematics. Let's get to the video. So inside this box, you won't see calculus, differential equations, matrices, vectors, or fluid dynamics. So you will find simple arithmetic, basic algebra, geometry and trigonometry, and some physics equation and plug and play aerodynamics equations such as our lift equation. In fact, this is the syllabus given by EASA, who is the European Aviation Regulatory Authority, for someone who's going to study aircraft engineering. So why? Why is it so simple? Because aircraft maintenance engineering is practical, so it requires practical mathematics. Let me show you a few examples. Let's just say you are checking the load on a hydraulics actuator. You still need to understand what pressure is. Pressure equals force over area. Or else you're rigging a rudder or a flap. You need to know the angles. Or troubleshooting an electronic component, V equals IR, you need to have an understanding of that. Or to go a bit further, you find a crack in the structure. Now you need to do a damage analysis. How would you do it? You need to measure the damage, the length, the width, the depth, and then you need to check with the manuals to find whether it's within the limits or out of limits. So these are the day-to-day mathematics you would use in aircraft maintenance. It's not a lot to do with mathematics, but it's more to do with your hands-on experience. Now let's move to the other box. Please give me a few seconds of your time. I'm going to promise you something, that I'm going to bring the best aviation content out there and to the best of my ability, and to make sure that you understand every single bit of it. So for this, I really need motivation. I just found out recently 89.7% of you who watch my videos haven't subscribed to my channel. So if you really think that you gain some sort of a value out of these videos, please subscribe to my channel. I have a dream, and that is to have 5,000 subscribers by next year, and only you can help me. If you really think I deserve that 5,000 subscribers, please do help me. Now these engineers are different. They require calculus, differential equations, partial differential equations, vectors, matrices, CFD, computation fluid dynamics, and also finite element. They use a lot of maths in their studies. Now to give you a few examples, these engineers derive equations using calculus to find pressure fields on a wing. And they build finite element models of different structures with 100,000 unknowns. And these engineers simulate unsteady airflows using equations such as Navier-Stokes principle. And these are boss level mathematics. And also, these engineers actually write the instructions for aircraft maintenance engineers to follow. So these are some of the questions that I have done in my degree and some of the assignments that I have completed. But they do not have a standardized syllabus like the aircraft maintenance syllabus, but you will find calculus, differential equations. There is this common set of mathematics every engineer should know. Now if you ask me as an ex-aircraft engineer and a current aeronautical engineer, which one is better? Well, one isn't better than the other. These two engineering serves two different purposes. Aeronautical engineers, they design, simulate, analyze, they do a lot of things with mathematics and a lot of data. Aircraft engineers, they have the instructions, they follow the instruction, they maintain the aircraft as per those instructions. And aircraft maintenance, you work with the aircraft. Aeronautical engineering, sometimes you won't even see the aircraft. You're doing a desk-based job mostly. But that doesn't mean you won't work with an aircraft. You are still working with an aircraft, but behind a desk. Now, if you're struggling to find which one is better for you, you can book a call with me through this email and talk to me, and then we can discuss which one is better. To do aircraft maintenance, we have partnered with two schools, one in Switzerland and the other one is Latvia. And to do aeronautical or aerospace engineering, we got one school in the United Kingdom. So you can get information about those schools as well. Now let's jump into an exam question and see the depth of mathematics that requires in each of these domains. So let me teach you something. So in a bit, we are going to attempt 2 questions. Now before attempting them, I thought it's better to give you some context. So the questions that I'm gonna do is regarding boundary layer. Now I want you to explain a bit what a boundary layer is, so you understand and you can understand while I'm doing the exercise, because I'm not going to talk and explain, and I'm going to, some of them I'm going to rush through, some of them I'm going to cut, because the aeronautical engineering boundary layer question was a bit long, so I had to cut it and make it fit within the video. Before we go into this, let me explain what a boundary layer is. A boundary layer is formed when a fluid, let's take this cellophane tape as the fluid. Now when there's a surface, let it be an aerofoil, now this air will come and then hit on the surface, and right where it hits on the surface, it tries to stick with the surface. Now this creates a layer. So this is what we call a boundary layer, and there will be air layers going on top of each other by creating frictions, and that will create different velocities between these layers. So let's look at this and we'll get a bit more clarity. So this is what I was talking about. Now this is a surface and this is air coming in contact with the surface. Now the air layer that is in contact with the surface will have 0 velocity, and the layer above will have friction with the layer below, and it will have a slightly higher velocity, and this one will have a slightly higher velocity, this one will have a slightly higher velocity. Why? Because there's friction between the layers. So there are 3 things I want you to know. That is free stream condition. Free stream condition is air before it reaches the surface, so it will have normal air velocity. And the second one is no slip condition. No slip condition is the layer that is directly in touch with the surface, so it will have 0 velocity. And the next one is 0 shear condition. 0 shear condition means, now you know between different layers there is different velocities, okay, and the one at the outermost layer will have a velocity similar to the free stream condition. Why? There's less friction, so that one we call 0 shear condition. Okay, so now let's look at the question so you will understand it a bit better. Now as I explained previously, the question number 1 is an aircraft maintenance engineering question where I am going to find the velocity at the outer edge of the boundary layer, that is the topmost layer of the boundary layer where the friction is the least. In the aeronautical engineering boundary layer question, I calculated the constants that shape the velocity profile inside the boundary layer so it matches the real airflow behavior. Now I hope this video was helpful. If you really think this video helped you understand the different level of mathematics between two, maybe have an idea, please subscribe to my channel and show your support so I can do more videos like this in the future. So this is it for today. I'll come back with another video next week. Until then, keep fixing.